Please Look Up is recorded at SciTech on Wajak Noongar land. Good evening, everybody, and welcome to Please Look Up, the monthly podcast produced by Particle, where we take you through a guided tour of the night sky as seen from Perth, as well as taking a deep dive into some of the more out-of-this-world space news. In this episode, we'll be discussing what you can see in the night sky in the month of August. My name is Leon, and I'm joined by Amanda, a professional presenter from the SciTech Planetarium. Amanda, thank you for being here.
Yeah, thanks for having me.
We'll start where we always do and ask, if I'm outside looking at the night sky, what can I expect to see in the month of August? What sort of planets are out there?
Yeah, well, if you're interested in planets, I recommend going and checking out Mercury. So it's up just after sunset. You'll be able to see it for an hour after sunset, low in the western horizon.
Mercury in the west. Okay, good.
Exactly. And then just up and above, slightly to the right, you might also be able to see Mars, although Mars is a little bit dim at the moment, so don't despair if you can't see it.
Okay, Mercury and Mars. So will Mercury be the brighter one?
Yes, and it'll be lower to the horizon.
Oh, gotcha. Yep. Is Venus still up in the west?
Venus is up in the west for another couple of days, but after this weekend, it will have set.
Oh, good. Okay, it's been up there for fucking ages. So I throw that in there for
fun. Venus is still there. What are you doing, Venus?
So Venus has set in the west.
So basically Venus is in between Earth and the Sun at the moment, so it's going to be right next to the Sun in our sky. So it'll be up during the day, but you won't be able to see it. But then in a couple of months, you will see it rising at sunrise as it passes the Sun in our sky.
Oh, gotcha. So it's like overtaking Earth as it moves around the Sun.
Exactly.
Right, and I see what you mean. If you want to look at Venus, you need to look in the direction of the Sun, also known as daytime.
Yeah, not a great time for planet gazing. But yeah, in a couple of months when it's up in the morning, you'll be able to see it again.
Good to know. All right, so that's Mercury, Venus, and Mars all there. That's nice. What about the two big ones?
By that we mean Jupiter and Saturn, I assume?
Yes, that's the one.
So Saturn's at opposition at the moment, which means it's on the other side of the sky from the Sun. So at about sunset, you can turn around and face east, the exact opposite direction, and you'll be able to see Saturn rising in the eastern sky. And so what it means at opposition is, like I said, it's on the other side of the sky. It also means that Saturn will be really bright in the sky because it'll be completely lit up. We'll see the entire daytime side of Saturn. So it is a good time to go spot it if you're interested.
Excellent. So if you've got like well, you don't even need a telescope, but if you have one.
Yeah, if you have one and you see something quite bright on the eastern horizon just after sunset, whip it out. You might be able to get a closer look at Saturn. And if you feel like staying up a while, you might even get to see Jupiter rising at about midnight.
At about midnight. Okay. So, yeah, Jupiter's been like that for a while. You need to be up either very early or very late to see it. But definitely going to check out Saturn. And I guess it makes sense, opposition being it's opposite the Sun in the sky. So is that like a generic word to describe whenever a planet is opposite the Sun in the sky? Is that what we call opposition?
Yep. That's opposition.
Good to know. So those are the planets that we can see. What else is happening in the month of August?
Well, this month you will get to see not one but two full moons. So as of recording this, we have missed the first full moon. That was on the 2nd of August.
Yes.
But don't worry, because there's a second full moon on the 31st of August, which we call a blue moon. So
a blue moon?
Yes. Okay. It doesn't look blue. Nothing about the moon is different. It's just the fact that it is the second full moon occurring in a calendar month.
Right. Oh, okay. So on the 2nd of August and the 31st of August.
Exactly.
Yeah.
But these full moons are special for another reason. The moon is currently at the closest point it gets to Earth in its orbit, called perigee. So we have a supermoon, which means it looks a little bit bigger in the night sky and a little bit brighter. So if you've noticed it looking a bit bigger and brighter, you're correct. And if you haven't, don't worry, it's not that much bigger or brighter. Gotcha.
Yeah, I have heard about this phrase, supermoon. So it's just because the moon is full while it's at its closest distance to Earth, is that right?
Exactly.
Yeah, okay. Going back to the blue moon, is that where the saying once in a blue moon comes from?
Exactly. It's not exactly a common occurrence because the moon is full every 28 days and a month lasts about 30 or 31. So typically you only get one in a month. So
right, okay. And when you get two, it's very uncommon. Yeah, that makes sense. Okay, I can see where that etymology has come from. All right, so that's the moon, the natural satellite of the Earth. what about an artificial satellite? Can we see the International Space Station? Are there any predictions of when we'll see it from Perth?
Yeah, definitely. So if you're a bit of an early bird and feel like getting up before 6 o'clock in the morning, then on the 9th of August at specifically 5:53 a.m, you will see the International Space Station pass over the sky. So it'll move slowly from west-southwest to north-northeast. However, if you don't feel like getting up, you could try...
That's not going to be me.
No? Well, then you could try the 16th of August at 6:25 p.m. So you'll see it move from northwest to southeast across the sky. But if neither of these dates work for you, that's okay. You can go to the Spot the Station website to check when you're going to be able to have an opportunity to spot the ISS up there.
Ah, good to know. So the 9th or the 16th, or just ask the internet.
Exactly.
Yep, good to know. And what about any interesting stars or constellations? What's up and interesting in the sky this month?
Yeah, well, Scorpius is always a good constellation to try to spot up there.
Yes, heard of Scorpius.
Exactly. Famously looks like a scorpion. So if you look up in the sky, you'll be able to see the curling tail of the scorpion. That's always a good way to spot it. Mm-hmm. You can also try and look for the heart of the scorpion, Antares, which might even look quite red if you have a good enough view of the night sky.
Oh, so a red star, you're saying?
Exactly. Now, Antares actually means not Mars because the orbit of Mars takes it right past Antares.
Sorry?
And at times people used to get the two confused. So they call this one...
Antares means not Mars.
Not Mars.
That's pretty funny. Oh, you're so right. So Mars right now is on the horizon, but you're saying like the western horizon at sunset. Mm-hmm. But as it moves through around the sun, as it moves through the sky, it sometimes gets close to Antares.
Yeah, exactly. So the planets do move through the sky and Mars's path will take it past Antares.
Oh, I see. And you could easily get confused.
Exactly.
So yeah, that's Mars and that's not Mars.
Exactly.
That's pretty funny. Am I remembering correctly that the Scorpius star pattern is the same star pattern they talk about in the Moana movie?
Yeah, exactly. So if you've seen Moana or you're just familiar with Hawaiian legends, you might have heard of Maui's hook.
Yeah, Maui's hook.
Oh, yes. It's sort of looking at Scorpius the other way around, and it views the scorpion tail as the hook.
Oh, okay. Yeah, you're right. I see what you mean. So it's the same stars, just different cultures seeing different patterns.
Yeah, exactly. Typically we use the Greco-Roman stories, and that's typically what we see represented up there. But yeah, different cultures around the world will have different stories of what they see.
Great. All right. I know what I'm looking for. Any other exciting constellations while we're at it?
Oh, yeah. Well, Sagittarius is up there. So Sagittarius is a centaur in the night sky. But if you look at the heart of Sagittarius, you might also be able to spot a teapot.
A teapot? A pattern of stars shaped like a teapot?
Yeah, definitely trust me on this one. Or you can look it up online. Go to Google and type in the teapot in Sagittarius.
Right.
You will be able to spot it. And it is worth going out and trying to find the teapot because the spout of the teapot actually points you right to the centre of our galaxy.
Oh, really?
Yeah, and so especially in Perth, you're not actually going to be able to see anything there, but you can use that T-point to be able to point out to your family and go, oh, I know that's where Sagittarius A star, the black hole at the centre of our galaxy, is.
So the black hole, so that's just a coincidence. The teapot pattern of stars is there, and it points to the centre of the galaxy.
Yeah, okay, it's no divine constellation, but we do draw a picture there, and it does happen to point to the...
We're retrofitting the story to it, and so it points to the black hole at the centre of the galaxy. Mm-hmm. You said it was called Sagittarius what?
Sagittarius A star. So the way we label things in the night sky is by using the constellations. That's why we have a set of standardized constellations. And the most interesting thing in the constellation of Sagittarius is the black hole.
Okay. And does the little star we say at the end, Sagittarius A star, has got nothing to do with it being... It's not a star.
No, it just has that little star symbol you see on your keyboard.
It's an asterisk. Gotcha. Sorry. So even though we can't even see it especially from Perth with just our naked eye, how do we know that there's even a black hole in the centre of the Milky Way galaxy at that position?
Yeah, so it's a good question. Physicists did predict that there could be a black hole at the centre of our galaxy as early as the 1950s. However, we were only able to gather indirect evidence for its existence. Going back to the last 10-15 years, we became more confident, and this was mostly done through observing the orbits of the stars in this area. We could see that they were orbiting something incredibly massive, but still fairly small for how massive it must be.
Oh, right. So we looked at the stars near the centre of the galaxy and they sort of gave it away.
Yeah, exactly. So we could make predictions based on all this evidence that, yes, it's probably a black hole there, but we didn't have direct evidence of it until 2022. So only last year did we actually finally manage to photograph the black hole at the centre of our galaxy.
Amazing.
So that was with the Event Horizon Telescope. You might have heard of that one.
I did hear about it briefly, yeah.
Yeah, so they managed to use basically a bunch of radio telescopes all around the world, and they linked them up to create a virtual telescope that's basically the size of the entire Earth. Okay. And so this finally had enough resolving power to be able to detect the black hole at the centre of our galaxy, and we got a photo of it for the first time.
Wow, that's really interesting. So you spoke about how it was sort of theorised since the 1950s, and then over the last sort of 20, 30 years, there was sort of this extra... it's still indirect evidence, but quite strong evidence of these, like the orbits around this very small object in the centre of the galaxy. And now, literally, only last year did we get an image of it.
Yeah, exactly.
That's fantastic. Well, I guess that's the story of progress. That's how science works. I like that. So now we know for certain, beyond any shadow of a doubt, that there's a black hole there.
Yes, well, as confident as you can be with photographic evidence, I don't know what more we could provide there.
Pixar, it didn't happen.
Exactly.
Let's leave Earth behind for a bit. Is there any other interesting big news in the big wide world of space?
Yeah, in terms of space news, there was the launch of Chandrayaan-3. So this
Chandrayaan-3.
Yes, and it was launched by the Indian Space Research Organisation, which is basically India's version of NASA.
Yep.
So they launched this mission on July 14th, and it's actually a moon mission. So they're sending up this spacecraft on the way to the moon right now, and on board is the Vikram lander and the Pragyan rover.
The Vikram lander and Pragyan rover on the way to the moon.
Yeah.
So, I mean, the name suggests it's probably going to land, but would you tell us in a bit more detail? What's the mission going to do?
Yeah, well, first of all, it actually has to come into orbit around the moon, so it'll do that on about the 6th of August.
Oh, so, okay, it's on its way to the moon right now, but it's not there yet.
Yeah, so it's on its way. It'll get into moon orbit, and then the orbiter stays up in orbit around the moon, and then on the 23rd of August the Vikram lander will touch down on the moon containing the Pragyan rover.
Oh, gotcha, okay. And so is it the Pragyan rover intended to drive around on the surface, is that right?
Yeah, exactly. It'll drive around, study some moon rocks, look at the plasma out there, see what's happening on the moon.
So whereabouts on the moon is the Vikram lander going to go?
Oh, yeah, great question. So it's actually landing near the South Pole, or the lunar South Pole. So the South Pole of the moon is about 70 degrees south, which actually from our perspective in Australia, when you look at the moon in the night sky, is up near the top of the moon because we're all a bit upside down here.
Upside down, right?
Exactly. So from the perspective of us and anyone in the southern hemisphere.
So why is it landing in the South Pole? What's exciting there?
Yeah, the South Pole is actually an interesting place in terms of the moon because we have evidence that there's water there. Now, it's not like lakes of water or an ocean of water or anything like that. It's just that we think there are molecules of water in the soil there as opposed to it being completely dry. And because some craters at that part of the moon where it's quite south are permanently in shadow, there could even be ice deposits of frozen water within the craters on the surface of the moon.
Oh, okay. That's really cool, actually. All right, I'm getting vibes of like in Antarctica where the sun is just below the horizon for months and months at a time. Yeah. You're talking about these craters in the South Pole where it just the sun never shines.
Exactly. So these ice, the ice we're talking about on the moon, not quite like the Antarctic poles, but it's the rough same location, and there wouldn't be sunlight. Just like sometimes there's no sunlight.
Yeah, sometimes in the poles on Earth. Yeah, okay, that's really cool. All right. Now, just to check my understanding, you've mentioned an orbiter and a lander. So is there the orbiter is that staying around the moon? Is that right?
Yeah. So that's where it gets its name from. The orbiter stays in orbit around the moon, and the lander comes down and lands on the moon.
Yeah.
So the lander carries with it the Langmuir probe.
Okay.
So that is going to be studying plasma density on the surface of the moon.
Oh, that's exciting.
Yeah. So it's pretty exciting because, okay, you're probably wondering why is there plasma on the moon?
That was my next
generating that.
Why plasma? Yes.
Yeah, and the answer is actually pretty simple. It is the solar winds coming off of the sun. So they ionize the particles there.
Oh.
Yeah, but this phenomenon doesn't occur on Earth.
No.
Because we have an atmosphere to protect us.
Yeah, right.
But unfortunately for the moon, there's no atmosphere there to protect it. So its particles get ionized. So we're there to study the plasma forming there.
That's really clever. I'd never even thought of that you don't have this effect, at least not at the surface of the Earth, just because of the atmosphere.
Exactly. And the lander will also be carrying a laser retroflector array. So
Okay, that's a mouthful.
It's kind of like a fancy mirror, but basically when you shine light on a mirror, it reflects back at the same angle. So if you look straight on at a mirror, you know how you see your reflection.
Yeah.
But if you look at a mirror sideways, you don't see yourself,
No,
you see
yeah.
something on the other side of the room.
Yes, that's right.
Well, this doesn't do that. This will always reflect light directly back to the source.
Huh, that's really cool. So, like, I see what you mean. So it's an array of mirrors. It's in the name there.
Yes, exactly. So all those different, that array of mirrors will allow the light to be reflected straight back.
Back to the
and
source.
that means that we could shine a laser on it from down here on Earth, and we could study the orbit of the moon using this.
That's really clever. So the laser light bounces off the moon, and essentially that tells you how far away it is, and you determine the orbit and speed and things from that data?
Yeah, from the laser bouncing back to us. So that's
Right.
why we have to use one of these arrays rather than
you
a
need the
standard
laser
mirror.
to come
Otherwise,
straight
the
back to
laser
you.
would bounce off into space somewhere.
Yeah, yeah, okay. It's so obvious now that you say that. That's so clever, isn't it? That's cool. That's really interesting science. Any other exciting science
Yeah, well,
Yep.
also it does, that lander does carry with it the rover, as we said, the Pragyan rover.
Yes.
And it's going to be driving around and looking at the composition of the rocks and the soil. Like we said, it seems like it'll be an interesting place because there might be water in the soil as opposed to being completely dry.
Mm-hmm.
So that rover mission will last about 14 Earth days, which actually
14
is
Earth days.
1 day on the moon.
So the rover mission is expected to last about 14 days, you say?
Yes, exactly.
Yeah, okay, studying the rocks. That's really interesting. And that's happening on August 23. That's pretty cool. Like, moon landings are exceptionally rare. Obviously, we haven't sent people there for 51 years, but even robotic landings, that's really exciting. On the 23rd of August, I know I'm going to be looking forward to that. Well, that seems like a great place to end. Thank you so much for being here, Amanda. It's been a real pleasure.
Thanks for having me.
That's it for this episode of Particles Please Look Up. We'll see you next month where we talk about the night sky and the space news for September. If you want to hear more interesting space news, check out the website particle.scitech.org.au for more information.